Ron Westrum, PhD. Sir, we're so thrilled to have you here with us. I've been following your work for years, background in naval aviation. Of course, the DevOps community has been following your work. You've worked with Gene Kim, Jess Humble. You've actually worked with a lot of folks that we know, like Sidney Decker, Dr. Woods, Hallnagel. You're known in the safety community. You're known for a continuum about culture, pathological, bureaucratic, and generative. Your work is out there. You work with, I believe, Carl Veik. And then I got to tell you a quick story. I'm working at Navy Warfare Development Command several years ago as a reservist. On the weekends, we're bored. We're looking at the paint dry on the walls. There's a library. I'll go over to the library and I start looking at a couple books. And there's a book called Sidewinder. Believe it or not, the author has the same name as you.
I can't believe that.
I know. So I'm looking at this thing going, wait, is that the Ron Westrum that I know? Or I think I know? So I started opening it up. I'm like, this is amazing. He wrote a book on the Sidewinder AIM-9 missile. So glad you're here. A lot to talk about. I just want to know, is there anything that you want to get out of this today in this conversation?
I want to have fun like everybody else.
Well, I don't know if we can do that. We'll give it a shot. So many things to talk. We'll get to the culture stuff later. I think what we ought to do is go back in time and build out a timeline and talk about the AIM-9, see where these paths cross between John Boyd. We'll look at EM theory. We'll get into even the Navy's Top Gun. We'll talk about innovation and then move that over to things like Deming and into the culture discussion that's happening in the DevOps. Maybe we'll call this flight ops to DevOps. I don't know. We'll have it something. So yeah, it'll be fun. So Mark, going back to John Boyd, 1950s, walk us through what John Boyd's doing, Mark, in 1950s.
1950s, John Boyd, coming fresh out of the Korean War, is now a fighter weapons instructor at the Fighter Weapons School at Nellis Air Force Base. And as a senior first lieutenant and young captain, he creates the aerial attack study, which becomes the definitive air-to-air combat study for all NATO air forces, still in force today, has been unclassified, and anybody can download this and read it. It's one of his contributions and something that he did in his free time as a young junior military officer, which is absolutely insane.
And a few years prior to this, Dr. Westrum, you pick up in your book Sidewinder, what's happening in China Lake.
Well, let me talk a little bit about China Lake. This was basically a rocket development facility and even a production facility during the Second World War. A bunch of people from Caltech were asked to develop rockets, and they looked for a place to do it. They started doing it in Pasadena originally, but you can imagine firing rockets in Pasadena is not necessarily a good thing. So they thought, well, we need some space to do this. So where did they look? They looked in the Mojave Desert, and there was this huge area near China Lake, which of course there's no lake. It was next to a village called Ridgecrest. There's no ridge. And so they then developed rockets during World War II. The rockets were very successful. And in fact, many people involved in that were later to be important in the space program.
Yeah.
And then about essentially in 1947, Bill McLean, who's a person who's working at the Bureau of Standards and developing fuses for rockets and missiles and things like that, is gotten out to China Lake essentially to study toss bombing, which is something that, in fact, he doesn't do. Mm-hmm. What he does do is he begins to study the problem of the pilot who has to hit a target. And essentially the main things that you could use back then were machine guns and rockets.
Right.
Okay, well, machine guns are good, at least at short range. And rockets are good too, but the problem with rockets is that if you have a plane, especially a jet plane, it's moving around.
Right. So, unless you're in the movie Iron Eagle, which we saw this years ago, where they're on the ground and they use rockets, I think Zuni rockets, to shoot another plane. But continue, please.
Okay. So the thing is, he realizes, in looking at all these things about aiming rockets and so forth, that the real problem is that the airplane that's the target can move. So, obvious thing, put the guidance in the missile. And he chooses to do this with infrared. Okay. So infrared actually was not very popular. And the reason was that basically infrared isn't going to work real well if you've got night and clouds. So he decides that nonetheless he's going to do this, because if you can't see the target, you probably won't hit it anyway. So he said, if it works in the daytime, that's good. And the big problem with radar is, of course, it's complicated. I mean, a good example was the Falcon missile. It had about 90 tubes in it. And a time when you had 90 tubes in a guided missile, it didn't leave a lot of space for other stuff like the warhead.
Right.
So you had to actually hit things with the Falcon. You couldn't use the proximity fuse, at least not originally. So McLean then essentially engaged in an illegal program. It was illegal because China Lake had been told they were not to develop guided missiles. They were just to test them. All right. So, of course, at China Lake, changing orders was a habit. It was a reflex. This is what you've asked for, but we're going to study this and decide whether we want to do this or not, or do something else. And in many cases, that's exactly what they did. So what they did is they hid this project. And China Lake had extra funds left over from World War II. Extra funds could be used on research projects. So they began developing what they called an intelligent fuse. It was number like 534 or something. Well, 534 was actually the number of the weapons officer's phone extension. It was BS.
Very creative.
So they keep working on this, and they know they're not supposed to be doing it. So they got to disguise it. And there's a missile czar who's managing all this stuff and so forth. And the missile czar, if he hears about this, he's going to have a fit. So what they keep this project hidden until finally they get a good enough seeker so they can demonstrate it to other people. Once they start demonstrating what the seeker will do, and remember, it's very inexpensive because it's like the cheapest thing that they could do with maybe 14 radio tubes. Mm-hmm. It works. And all of a sudden, they bring in some Navy brass and they take a look at it and they say, whoa, we have to have this missile. And plus, it only costs 1/10 of what the Falcon and stuff like that is going to cost.
Right. And
unlike Sparrow, it's 1/10. Terrific. Okay. So they decided to go ahead and develop it. And of course, it works fine. Well, it didn't work fine at first. And, It took a lot of adjusting, but eventually they got it to be able to hit a target. And then they made more of them. And then, the rest of the story happens. Basically, they sent it out to the fleet. They sent it to get people from the Air Force to come in and test it. The Air Force thinks we've got to have this too. And so that's basically the story. So this becomes then part of air combat, which of course, in the eyes of the Sidewinder developers, the basic point is you press a button and you knock out the other plane. Well, in real life, of course, it doesn't work that way.
No.
Yeah. So then they realized that they had to do more. Okay. And they had to have seekers that would hit, targets with different kinds of missions and so on and so forth. But they did all that stuff. And eventually you got up to something like the AIM-9L, which was basically a all-aspect missile and so forth. And in the meanwhile, of course, the Russians had gotten a copy from the Korean War. Or was it Korean War? Or maybe it was
one of them got stuck in a MiG, I think, and they
exactly.
Flew back.
Yeah, that's the point. So that may have been it. Also, somebody basically, we had a spy, Colonel whatever his name from Sweden, and he took off with the blueprints and so forth.
So you got to be careful with those Swedes, especially when they come on your show and talk about John Boyd. That we've had the Swedish folks come on. It's awesome. No, I know they're going to listen to this.
Yeah. So anyway, that's how the story. That's how it, all this goes along. And the big problem was that when it came time to have a missile that you could have guidance from your helmet on and so forth, they decided not to do it. The Navy decided not to do it, not China Lake. Right. And of course, then the Russians went ahead and did that anyway. So that's pretty much the guided missile field. It's like you do this and you do that, and you try to get better, and eventually you get something that's pretty good.
Yeah.
And of course, the real test of this was the Falklands War, and AIM-9Ls did a lot of damage to the Argentines. And fortunately, they worked real well, which the Argentine bombs didn't.
Yeah.
And if they had, basically, the war would have come out differently. There were a lot of bombs that got dropped and didn't go off.
Yeah. So just to frame a picture here for our listeners, the AIM-9 is the Sidewinder missile. It's named after a Sidewinder rattlesnake, I think it is. The IR seeking has an IR capability.
It's also infrared.
Yeah, right. So it has, I forgot the original name they gave it was like flamingo or something like that. Could you imagine
that
Navy guys, flamingos everywhere? But that's not that I saw that in your book when I was going back through my notes on it. So we have the Sidewinder missile from the movie. I hate to bring it up, Top Gun, the original Top Gun in 1986, fighting MiG-28s. Those are Sidewinder missiles that are going after the quote unquote MiG-28s, and update it to Maverick, the movie that came out a few years ago, same type of thing. These are the weapons that you see coming off the rails and turning really sharp and going after each other. It's a heat-seeking weapon, shorter range weapon. We call it a Fox 1. No, I'm sorry, it's a Fox 2. Did I get that? I'm gonna get people are gonna laugh at me on that one. It's a Fox 2. Yeah, wow, boy. Sorry about that, everybody. It's been years. So these weapons are pretty powerful. I think at one point I read there's over 100,000 made in the U.S. or even more. I mean,
that'd be a good guess. I'd have to talk to Raytheon and ask them, or whoever's making them now.
Yeah. Yeah, and then today, the new capabilities, a lot of high off-bore sight capabilities with them. And if going back to what Mark brought up with John Boyd, the aerial attack study was created right about the time that AIM-9 was coming into not only development, but the Air Force even picked up from the Navy. Again, I want to point out something very important. There's a theme here with John Boyd. Air Force doesn't like John Boyd. John Boyd, writes the aerial attack study. The Navy creates something pretty cool, an AIM-9, and the Air Force picks it up a little bit later on. But I think there's an important story here about the innovation behind the AIM-9. And I just want to reference something in your book here about McLean's approach to doing this. And that's provide an environment where unfettered inquiry can take place. Right? So that's kind of like a little close to psychological safety. People can provide their own input. Encourage integrated problem conceptions, experimentation, and testing. This is what we talk about, probing and experimentation, hypothesis testing. It's the same thing that John Boyd talks about later on in life when he builds the OODA loop. Use input from the ultimate users to shape the research process. Who is the ultimate user? Well, it's probably going to be a fighter pilot in this case, somebody who's going to actually engage in aerial combat. The fourth point you have in here is encourage competition. What we talk about, let me build on it more. Encourage competition between teams and laboratories. We want multiple safe to fail parallel probes when we're trying to figure out new technology. And you can create competition in your organization, of course, collaboration as well, but you run multiple safe to fail probes. And that's what we get today from not only John Boyd, but from Dave Snowden and the folks in the complex adaptive systems thinking world. Judge the effectiveness of the system by the performance, not the paper studies. Don't tell me what this looks like on paper. And Mark referencing F-16, F-17 a little bit later on too. Make sure we come back to that. And produce only what has been shown to work, right? Don't produce something that has no customer testing. So when you're looking at the development of the Sidewinder, and I think that's kind of where we're going with this right now for the moment, is that's what you saw in reflecting back on the development of the Sidewinder. Can you elaborate more on this?
Sure. The thing to understand is that basically the R&D process is also an OODA loop, because when you were working on this stuff, there are short ways to get to the solution and there are long ways. And basically at China Lake, they took the short way. And in many cases, they would simply take apart and put it on the missile after carefully documenting what the part actually looked like, not according to what the drawing said, but what it actually was. And then they would test it. And so what happened is a lot of steps got skipped. This is also true of the Lockheed Skunk Works, where again, they were much more interested in how the thing really worked as opposed to how it was supposed to work.
Right.
And Bill McLean in particular tried to get all of the people who were involved in this in the same place at the same time with the same thoughts and so on. So everybody, including the technicians, very important, were on board, and they wanted this to work. And the reason was that people who were doing the testing at China Lake were basically people who had been circulated in from the fleet. The big problem with a lot of the testing that was being done by the other companies is they had company test pilots.
Mm-hmm.
And I'm not going to knock that, but the basic point is if you've got a company test pilot, they tend to be forgiving. Okay.
Yeah.
Real life will not be forgiving. So if you get a test pilot that's too friendly to the firm, they're not going to give you the bad reports. You bring in somebody from the fleet and they're going to say, blankety blank, I don't care. This is not working. This is stupid. You guys are a-holes for doing this and blah, blah, blah.
Yeah. Follow the money and systems drive behaviors. That's key to that, right?
So that's the thing, is that you've got all the different parts of this thing are working together closely so that you can get all the information you need in the same space at the same time so they can make a decision quickly.
Yeah.
Right. Now, I want to tell a story about that.
Okay.
Okay. So this issue of getting the information in the same place is really important. It was a critical thing in the development for the Navy of the Combat Information Center. Okay. And I believe it was Nimitz essentially who said, you have to have a Combat Information Center, but he didn't tell them what that was going to be. So you had all sorts of different people doing different kinds of combat information centers, and they picked the best one. At least we hope they picked the best one. So the interesting thing about that, of course, is that idea of getting all the information together quickly became, for the airlines, the way that we got CRM, Cockpit Resource Management. All right. And I got interested, by the way, in this when I was in Scotland on a sabbatical. And I used to go down to the library and I would read stuff on aviation medicine and so forth. Well, here was stuff on cockpit resource management, which back then was an idea that was essentially a concept. They really hadn't gotten it together. But United Airlines and NASA got together and they developed this idea of cockpit resource management. Well, this is a great idea. And there are lots of applications. So you can even do this in medicine where you've got surgeons and things like this. And of course, this is the secret of the Mayo Clinic. The Mayo Clinic is they did cockpit resource management for surgical operations. So they would do a little slide or something like that, and they would freeze it and they'd use it right away. Okay. So you keep, narrowing the loop. So you're inside the loop that you need to have to be able to get this to work. Sorry about that. I should have disabled this. Anyway, so the thing is that if you've got a decision problem you need to make, the key is to get all the information in your hands at the same time. And by the way, going back in aviation, previous to the jet fighter, basically you had biplanes, all right? So their OODA loop was really long because in many cases, these planes were essentially planes that were trying to get information from, the enemy's infantry. So by the time you landed the plane, of course, the infantry situation had changed.
Yep. Yeah.
So a lot of this, and of course, eventually you got radios and things like that, so you could call people from the air. But the interesting thing is that here's a situation where you got an information flow problem. And when I started looking at information flow, that was the thing that I started with. How do you get the system to go faster? Okay.
Right.
So you don't lose the plane or lose the ship or, bad guys can't get away. So the same kind of thing, of course, eventually became the team of teams solution for the Army.
Yep.
All right. So this idea is really a powerful one. And I think that, that's another thing, is that there has to be inside the ship or the airplane or the spacecraft, some sort of ability to move the information quickly from the people who are getting the or the sensors that are getting the information to the people who need it. And that's the secret, So the OODA loop is not just, the fighter pilot, it's the whole system. And this is true in medicine.
Right.
It's true in manufacturing. It's true in R&D. The skunkworks idea is basically a a smaller OODA loop, because you get all the information together, the people, and you get the people that are really necessary, and so then you can get a lot of stuff done relatively quickly.
Yep.
I had a program at General Motors. We would bring in people from different skunkworks, and they would tell us what they did and how they did it. And that was a really interesting thing. I wish I wish I had the recordings of what we did, but that was a fascinating thing to see. So there are a variety of different situations where you need to get information to move quickly.
Right.
And so do you do this by shortening physical distance? Today it's all electronics.
Right.
And in principle.
You brought up CRM, which is what we call human factors, aviation crew resource management. It's foundational to team science. We've had Professor Eduardo Salas on here and Scott Tannenbaum. We've had Gary Klein, who worked a little bit on TADMIS, which was tactical decision making under stress. This is a precursor to aviation crew resource management. So as a co-creator of the flow system, we used aviation crew resource management to inform team science. And right now, John Turner, Professor Turner's at the University or Texas A&M University, expanding that training out more. It's complexity-based type of thinking. That is a human side of things. The CIC side is a human. Actually, it's not just human. It's a human and technology thing. It's us humans interacting with technologies with other humans. CIC, and there's a great book by Trent Hone. Trent Hone and I, we did some work together a few years ago with Dave Snowden up in Quantico. We did a OODA Loop Cynefin workshop, and Trent's there. And this is about the time Trent published one of his books on the CIC, looking back at the innovation there. So you were looking back at the 1930s, 1940s, late 40s and early 50s on the development of the AIM-9. And what I just heard from you is, and this is my interpretation, there's nothing new under the sun when it comes to innovation, right? We already know how to do it. We know how to create this type of context where innovation could emerge. And we'll talk more about that when we get to the cultural piece. But that's kind of what I heard from you in the last few moments there is these interesting connections that are emerging out of your experience looking back at innovation in the Navy. Am I correct?
Yeah, I think the interesting thing about this issue of rapid innovation is that people have known for years that having illegal prototypes is a fast way to get innovation. Mm-hmm. But given the nature of bureaucratic man, read U.S. Navy, this idea of illegal prototypes has never been a popular idea. And when I was at China Lake, the historian points to a series of volumes up on a shelf. And she says, see those books? She says, every time we did something, they passed a rule to make sure we couldn't do it again. And you might ask yourself, well, why would they do that? And the answer is the difference between smart knowledge and standard knowledge. Okay, so here's a new concept for you. Smart knowledge is a knowledge of things that work. The problem is that if you do it the smart knowledge way, you get in trouble. And especially if you acknowledge that that's how you did it. So it's one thing to do the smart knowledge, which allows you to get there more quickly. It's another thing to tell people that you did it. And time and again, what we have found essentially is the people who use smart knowledge. I got this from an anthropologist, by the way. Okay. People who use smart knowledge typically have to be very good at hiding what they're doing. The first paper I read, by the way, was on smart sex, which we don't have time to go into, but but the same principle applies. So the thing with smart knowledge is that in spite of the fact that it works, it's very difficult to get it into the system. Because to get it in the system would have to admit that they're not doing it the right way. Mm-hmm. Okay? So the fighter mafia are a perfect example of smart knowledge. Yeah. All right? Yeah. It's a perfect example. And, of course, those people tend to get in trouble.
Yep. The Mavericks. And that's the whole theme of this is we know that in ordinary times, you need to protect your Mavericks because those are the people that are going to help you when you need them the most, the Mavericks. That's kind of what you're talking about. I do want to come back to the timeline here that we were building out here to get more towards the 70s and all that, because there's so much more. We're gonna, because right now we're jumping back and forth between the 80s and 60s.
Can I tie it? Can I give a bridge? So kind of what you're saying, Ron, about information flow. So in Boyd's career interview, he's talking about when he developed the aerial attack study, and I think the first printing was in 57. He was saying that the next iterations into the early 60s were all classified. And he says the problem with them being classified is that no one could use them. So all the fighter pilots that wound up going into Vietnam didn't have access to, or it seemed probably less of them had access to the aerial attack study because it had been classified. And he also mentions in the that a lot of the maneuver development from that work came from firsthand Navy documents that he used as his primary resource.
And there is a chapter in his aerial attack study. It's AIM-9B missile, limitations of our weapon systems in a pursuit curve attack. So here we are. We have the AIM-9 moving out to the Navy, early mid 50s, or later 50s and the 60s now. And John Boyd picks up on this on his aerial attack study. So there's that other bridge there that we're coming into. And I think there's another one coming up in the early 70s when we get into actually Top Gun, right?
Yes, the whole idea. I mean, this is a perfect example of smart knowledge, is that the idea was essentially we've got planes with guided missiles. It's push button warfare. So we don't really need the gun anymore.
That didn't go well, did it?
It didn't quite work out.
Yeah.
And so the interesting thing is, of course, you also had to learn maneuvering. And that also was something that was taboo. Okay. You weren't supposed to be doing it. If you got caught doing it, you get sanctions. And so here we have stuff that works, and they know it works, but you can't use it because it's not standard knowledge. And unfortunately, the bureaucracy keeps doing this to us, and it's very difficult to hold them back. I mean, think about the pain suffered by the fighter mafia, and Burton also, was an attempt to get the personnel vehicle fixed up. The big problem is that bureaucrats like things that are linear and follow the rails, and that often is not the way to get things done. And in a war, a lot of times you throw that stuff overboard and you just say, well, let's get something that works right now, And that was the idea behind the proximity fuse. It says, I don't, you don't ask for permission. You just go do it. And the whole OSRD thing in World War II was basically an example of not asking for permission and just going ahead and doing it. And after the war, you would think, well, hey, let's study the organizations that were successful and what are their basic principles. No, they didn't do that. What they did is they got rid of all the skunk works.
Yep.
So when I was at General Motors in the 1980s, I tried to encourage them to protect their skunk works. And the reason was very simple, because the skunk works typically turned out the things that became the important GM innovations.
Yeah. So let's talk about skunk works. The way it's been described to me from Dave Snowden and others is a small group of people, limited resources, and a goal or a direction of travel that they're working on, right? So it's kind of, you force the informal network to work together in a way, so the collaboration is there,
right?
As opposed to putting an innovation office in your building and put the word innovation room or innovation room only. It's the only place you can innovate in your building. Can you walk a little bit more about what you learned about those innovation skunk works? What's the commonality
Absolutely.
between?
Well, so think about this problem. This guy named E.S. Vorm was going around the Navy asking people, what do you know about innovation? Is the Navy going to be ready for the stuff that's going to happen, like hypersonics and AI and so forth? And essentially, what you find is that a lot of times the idea starts in a place where it's not supposed to. Okay. So the obvious thing is then you take whatever apparatus you've got and move it to the person with the idea, and move the person with the idea to a place where they can do something. But the whole Navy is set up on the opposite principle. The things have to happen in a predictable way. You've got to bill it. You're going to have somebody fill it, blah, 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 blah. All right. So that's the thing. The thing about skunk works is, of course, most of the time skunk works exist illegally. They're like a hidden factory, as one of my colleagues at MIT puts it. And so you do it, but you can't talk about it. Jack Rabineau, actually, in World War II, in my book, I quote Rabineau, and he says, basically, you do everything on your free time, which starts at 8 o'clock in the morning and ends at 5 o'clock in the evening. And if your project is a success, that's wonderful. You're a hero. And if it doesn't work, you can kill it, and nobody's going to complain about it. Whereas if you don't have a hidden project, you've got to carry it on until doomsday. So somebody else will have to be the one responsible when the thing tanks. So the real question then is, okay, how do you get this? I'm a naval person. I'm sorry about this, but this is just how it is. So the thing about it is that you want.
We are too. We share your bias, Ron. So.
Yeah, we're Navy.
Yeah,
Navy
and Marine Corps. We're naval.
All right. Well, so the thing is basically, if you look at innovation in the Navy, and I really think that this deserves a serious study, that it hasn't got the Naval Institute Press refused to publish a book on naval innovation that was written by somebody who was one of my colleagues in the Sidewinder project. And but his basic thing was that you need flexibility. And the flexibility is because, again, the idea doesn't always occur to the person it's supposed to occur to. Right. Somebody else will have the idea. So how do you take that idea and develop it, giving the person resources and so forth to get this thing happening? And the Navy is still struggling with this. They celebrate the guys that, persisted, but sometimes, good example, SWAT ship. SWAT ship was designed essentially at the Naval Undersea Center, okay? The Undersea Center. So how do you think surface ships felt about the fact that this was being developed at an undersea laboratory? They didn't like it, okay? So at every step, they got in the way of the innovation process. They didn't want to have a big prototype, which was like 5 feet long, cost a couple million. They didn't want to have a bigger prototype, which was 90 feet long and cost a lot more than that, and so on and so forth. And they said it won't work. We know it won't work because, we've done studies and blah, blah, blah. Yeah. So what happened when they got the SSP Caimolino then is they literally had to take it to Hawaii to test it, because it would inflate the anger of the naval powers that be.
Oh yeah. So what's interesting here is the stories you're telling about what you saw with the Sidewinder and then the Navy are the similar type of things we saw with John Boyd. And in the 1960s, John Boyd goes off to Georgia Tech, learns a little bit about thermodynamics, builds on his economics background, and he comes out with this energy maneuverability theory. And that is basically how to, maneuvering fighter aircraft, and it affected fighter aircraft design going forward. So that's 1960s. It's kind of a closed system approach to thinking about how maneuvers work. Nothing wrong with that, given the right context. And then John Boyd continues this type of push of EM theory into the Navy and from the Air Force into the Navy. The wars going on over Vietnam. We have the Navy flying F-4s with no guns at the time. I believe they put the pod on a little bit later. Air Force flying F-4s, no pods, carrying maybe Sparrow 3 type missiles and early Sidewinder missiles, and things aren't going well, right? So we have the Sidewinder continuing to be center stage in the story, if you will. And then John Boyd discovers that the alt report comes out from the U.S. Navy that looks back at...
No, it didn't just come out. This didn't just happen, okay? So Captain Alt wrote as a carrier commander, basically, to Washington, and he complained about the fact that we were losing too many planes. And then one day he arrives in Washington, and he's escorted into a room, okay? So guess what? So there are two admirals. One of them is a rear admiral. The other is a vice admiral. They say, guess what, Captain Alt? You have the responsibility for fixing this problem, and you've got, 3 months to do it. You can have all the resources you want, but you have to come up with basically an improvement in performance by a factor of 2 or 3.
Okay. It's a great ad.
Oh, I mean, this is, so the thing is, so then he goes and he finds 5 experts, and one of the experts is an expert on um, guided missile design. Another expert is an expert on maintenance. Another person was working with the storage on board ships and so on.
Yeah, yeah.
And Alt and his people went to ships. They went to depots. They went to R&D laboratories, and they asked people, how can we do this better? And at the end of the road, basically, Alt says, okay, he puts out a report. It's got 273 recommendations in it. And number 273, if I'm not mistaken, is let's have a fighter weapons school.
Right.
And even that was done by smart methods. They
Yep.
literally stole the building.
Stole the building. Yep.
Stole the building with a crane.
Borrowed aircraft.
Borrowed aircraft. Absolutely. So
the same thing's happening here. So the emergence of the weapons school, the Navy fighter weapons school, because the Air Force already had a fighter weapons school, and John Boyd was already an instructor at that in the past.
Yes.
Now we're getting into early 1970s. Sidewinder kind of center stage still, not doing everything that we thought it would do. Plus,
but the Air Force Sidewinders are not as good as the Navy Sidewinders.
Why is that? I didn't know that.
Oh yeah, their seeker heads were inferior.
Okay.
I mean, don't ask me that in court, but this is pretty much how it was. So the thing is, the Air Force people said, well, how can we get the AIM-9D or the AIM-9L and stuff like that mounted on our planes?
Mm-hmm.
And the answer was, you can't. So they were stuck with the ones they had, and so they got good with Sparrows, I guess, is probably the answer to the situation.
So what's amazing about this is here we have John Boyd meeting with Navy Fighter Weapons School instructors, brand new ones that are pretty sharp, that understand mathematics as well. They're down in Eglin or somewhere in the Panhandle of Florida, and this is in Dan Peterson's book where he talks about this. Dan Peterson, Captain Peterson at the time, stands up the Navy Fighter Weapons School. I think he was captain at the time, or he retired as a captain. Anyway, John Boyd is all about his EM theory, early 1970s. And he points out to Navy Top Guns and says, you can't fight a MiG with an F4. You just can't do it. And the Navy Top Guns stand up and say, you know what? You're forgetting about the most important thing, the human in the cockpit, right? So this is important as in John Boyd's approach to later coming up with the OODA loop. So this is early 1970s. So you can start to see the connection here with the Sidewinder as a kind of a backdrop of how these things kind of weave together. EM theory, we have the aerial attack study, we have you talking about innovation, what Mavericks need or mean to an organization.
Lightweight fighter program.
And then now we're about to come in a lightweight fighter program with the fighter mafia coming up here. Are these kind of resonating with you, Doctor? These stories?
Absolutely. I mean, yes. The thing that you have to realize too is that, remember, you have the only OODA loop is not the one the pilot has. There's also one that the Navy itself has. Okay, so these missiles go off to aircraft carriers. What guarantees that the people in the aircraft carrier are going to be able to maintain these things and get them ready for combat in a timely way? All right. So there has to be constant. And by the way, the aircraft carrier itself was a determinant of how Sidewinder was put together. They went to talk to the carrier people and designing this, and they made sure that the missile was short enough so it could go up on an ammunition hoist. Because once you design the ammunition hoist, you got to have a missile that's going to fit. So that's why the heads of Sidewinders would come off. And it was good because in the head was where a lot of the guidance machinery was. So, but then of course you've got to then assemble the missile on the carrier. Where are you going to do that? Turns out the cafeteria was a good place.
So this is important. So for those of you who've never been on an aircraft carrier, life on an aircraft carrier, you're walking down the passageway and you're down in the cafeterias, and there are missiles on the sides and bombs sometimes, right? Usually you saw your AIM-9 that you could be armed up on your aircraft later on. You saw it when you're walking to that passageway. So it is pretty impressive to walk in those places, and that's one of the reasons we call it a high reliability organization. Is we're always operating at the edge of the envelope, if you will, in a complex environment. But yeah, I saw that in your book, and I'm like, yep, that's very
Well,
true. That's how we
so
lived.
to follow that argument, though, the other thing is basically remember all of this is a system. It isn't
Right.
just a guided missile. It isn't just a pilot and the guided missile. It is the organization that makes the guided missile. It's the organization that brings it to the ships. It's the way the missiles are treated on the ship. The pilots themselves become a part of the equation, and they have to have the training. They have to understand what the missiles can do. One of the things China Lake used to do is they would take a lot of time with the pilots. Actually, they're the pilots' bosses, the CAGs and so forth, who would come out to China Lake and they would get lectures on how this stuff worked and how it didn't work.
Yeah.
And they knew that 6 months later, when this team came back from Vietnam, they would have lots of comments about this. And the thing is that people at China Lake realized they were managing this system. And if they didn't give people the right information, they were going to come back and say, well, we lost such and such because this and that didn't work. So they constantly tuned the system. And that's the secret to making it work. You got to get all the different parts of the system and get them tuned together so it's acting as one big united whole.
So at this point in our story, John Boyd hasn't created the OODA loop yet. We're still 1970s. He hasn't thought about this yet. Mark's going to walk us through what happens with the on paper YF-17, YF-16. What's going on there, Mark?
Yeah, on paper, Boyd was really surprised by the results because on paper, he thought that the race between the YF-16, which became the F-16, and the YF-17, which became the F-18, he thought that it would have been a lot closer. But what he learned was that the pilots overwhelmingly chose the F-16 over what became the F-18, and that really puzzled and baffled him because the output from the the EM diagrams, energy maneuverability theory diagrams, would have suggested a much tighter race between the two.
And so we get the idea of fast transients out of that. Fast transients are now known as pivoting.
Turns, right.
Yeah, but yeah. So, the lean community or lean startup community calls it a pivot. It is a pivot. So there's a lot of cool connections here that are happening. And then there's a reason John Boyd goes searching for the next 20 years to understand how is he able to create the EM theory. Mark, go ahead.
Yeah, so Boyd, and talking with Chuck Spinney and Chet Richards, two of his close acolytes, Spinney being his closest, other than Pierre Sprey. Spinney told me that Boyd really started with this self-bewilderment. Like, how is it possible that I came up with EM theory when the Air Force has all of these astronautical engineers and aerospace engineers, et cetera? How did they not come up with this? And I, in my free time and all the other things that I have to do, I came up with it. And that sent them down the path. And the ultimate result of that was Destruction and Creation, which he published in 1976, which was his only published work, other than the aerial attack study. And then he riffed off of that for the last 20 years of his life, from basically from 76 to his death in 97. It was a continuous riff and building and refinement of what he had thought about with Destruction and Creation. It's like, basically, how do we learn and how do we interact and deal with reality? And how are we able to revise and update our own understanding of that reality to make sure that it is in harmony with the actual world around us, not what we perceive it to be? In other words, how do we keep our perception attuned to what's actually going on in the world?
But Mark, you left his question unanswered. How is it that John Boyd came up with these things and the other people didn't?
I don't know that he ever got to the bottom of that. I think that that's really the work that Ponch and I do, and a lot of others do, as we continue. I mean, he was clearly onto something, but I don't think he ever came up with an answer. And I think that everything that he had worked on is intentionally left open for us to try to figure it out. I think when you talk to his acolytes, they disagree. They don't have a clear agreement on what exactly he was chasing after. But I don't know that he ever came up with an answer. I think what we could say is that there's no way out, where our title comes from. There's no way out of the continuous whirl of reorientation and revision of models because of the state of the universe, with entropy, uncertainty, imprecision, and other things, that we have to keep breaking and revising our models, and that nothing's ever set in stone. But
So, but there's an obvious question to ask, and that is how many other John Boyds are out there, spinning their wheels when they've got an answer and the system isn't listening to it. And I bet you there's a lot more than you.
Oh, so in other words, do you mean to say, like, radicals that have come up with ideas that would work and change things, and then the bureaucracy smites them? And yeah. I mean, between my time in the military and my time in the asset management world on Wall Street, there's no question. I mean, the radical innovator is a pariah. That's why Steve Jobs, I believe, got fired from Apple the first time. Because he just wanted to keep going and updating and revising and orienting.
The Maverick is always a Cinderella. That's the thing to remember, because Cinderellas have sisters who don't want them to be there.
Right.
They want to win, okay? And so that's the problem with innovators, is that a lot of times the innovator's saying, well, I've got this terrific idea. And the guy looks at him and he says, well, you're not paid to have ideas.
Right.
So
yeah, Billy Mitchell was court-martialed.
Yeah. Well, so that's the obvious comparison. How come John Boyd came off as well as he did? Because he suffered some static, but
he did, and they never charged him. but he always had. What he was able to. This is Coram emphasizes this hard in his biography and in talking with some of the acolytes, is that he always made sure to have the homework done so that they had nowhere to go. But yeah, I mean, people still hate John Boyd. Like they still. We see it today all the time.
The thing at GM is every time they found a skunk works, they would kill it.
Yeah.
That was their policy. In fact, I went to one of the vice presidents who had done this program called Putting Quality on the Road, and she was a smart person. I said, the skunk works are actually producing a lot of your best stuff. And she says, oh, no, we don't believe in skunk works here at General Motors. But if you talk to the mid-level engineers, they would tell you that that's where a lot of the key innovations came from. So GM was literally killing its innovators by policy.
Yeah. It reminds me of Fountainhead by Ayn Rand, right? Howard Rourke was this, architect. He wanted to break all the models and reorient things, but everybody would fight and destroy him because they never wanted it to change. They never wanted anything to change or advance or progress.
Right. Well, I think the truth is innovators are usually under fire.
Yeah.
My favorite one is Admiral Sims, by the way. I think, a great innovator. And I was delighted. I gave a talk at the Naval War College, and here was a big picture of Sims on the wall, and I felt, terrific. But he was actually an acolyte of Admiral Scott in the Royal Navy, who was always in trouble. The reason that Sims met Scott was that Scott had been isolated and sent off to Hong Kong. So here were these two guys, an American and a Brit, and the Brit has a wonderful system for aiming and firing guns. And the American says, well, we have to do that. So he gets back to the United States, writes a letter to the president, to Teddy Roosevelt, and said, we have the system which we really need to have. The British are already using it. And so Roosevelt says, well, let's check this out. Check this out. See if this guy is telling the truth. If he's telling the truth, let's do that. And of course, that's what they did. There are lots of other guys who said, I have this wonderful idea. And they said, no, you don't really. Forget it.
I'm going to pick up on the timeline. We're in the 70s, going into the 80s. John Boyd's out of the military now. He's doing his, a discourse on winning and losing brief. A lot of work, doing a lot of research and things like Deming, Toyota Ono, Shingo. There's a strong connection here, I believe, to a lot of the work that you've done in the 80s and 90s. On your continuum. One of them is fear drive out of the organization, right? Now that's what we get from both, I think, the Toyota Way and Deming.
Yeah.
And then we also, you talk about a fearless organization, psychological safety there. So John Boyd's looking at all these things, and he later on develops or sketches the OODA loop, which we get, I believe, in 1995 or 96. The first time we see it, it's not a single loop. Unfortunately, my point of view on this from the safety community, safety professionals always draw John Boyd's OODA loop as a linear circle, like a single, a non-act or passive process. That's not how we actually sense the external world. In a recent book by Eric Hallnagel, he brings up the OODA loop and he gets it wrong, right? And this is kind of frustrating to me because a lot of safety professionals talk about the safety culture, a lot of your work, and they talk about the importance of information flow, and then they go out and they draw a linear approach to John Boyd's OODA loop, right? And it's frustrating because I'm like, this guy who sketched this thing looked at neuroscience, cognitive science, biology, anthropology, philosophy, quantum physics, came up with the EM theory, and I don't think he just drew a single loop there, guys. So that's one thing that frustrates me. That's the only thing that frustrates me about the safety community. I think as soon as they fix that, we're going to lower the energy costs associated with creating information flow within organizations, because Agile looks like safety. They're both emergent properties of a complex adaptive system. Resilience kind of emerges from that as well. And speaking of emergence or resilience, I brought up Dr. Woods earlier, Hallnagel, Decker, but you did some work on resilience engineering, correct? Can you walk us through where you are coming out of the 80s and 90s, what you're studying?
Well, we had something called a resilience core group that Hallnagel was basically in charge of. And it's really wonderful to look around the table and there's 20 other people who are really smart. And you think, well, this is a great place to be. And we did good stuff. I mean, we'd go to different countries and talk about their aviation system and so forth. And the diversity of the group was good because we had people from Japan, we had people from Sweden, we had people from Denmark and Norway and the United States, and those people are still, in my mind, the great the great knights of the round table. And it was just a delight to be part of that. And it was actually Hallnagel who got me to talk about requisite imagination. The idea,
I saw that. Yeah. So that's a play on Ashby's requisite variety, right? Okay.
It's a spin-off on requisite variety. I picked that up because, well, all of us folks copy each other. But the requisite imagination is really important. And it's really important because people, especially in the design process, have to think about what can go wrong. Okay, because things often do. And I'm not going to give you examples because I'm sure you have a bunch of them already. But the thing is that in requisite imagination, you really have to think about, okay, how can I design this system so nothing is going to happen badly? A good example, of course, was a moonlander. Because if you're on the moon and something goes wrong, what the bleep are you going to do? And fortunately, here's a little story for you. And it was what happened when the guys got back from Apollo 13. So they landed, embraced their families, so on. But the very next thing they did was they went to Grumman Aircraft in Bethpage, New York. And why did they do that? Because the people who had designed the moonlander were part of Grumman. And they had said, what if this thing became actually some sort of lifeboat? If it's going to be a lifeboat, let's put some additional food and supplies on it and so forth. So it can be used as a lifeboat if the main command capsule isn't working. That's what happened in Apollo 13. They had to have this lifeboat because that allowed them to cut down on the energy level, cut down on oxygen, all sorts of other stuff. It had all been foreseen in principle by the people at Grumman. And that saved the lives of those astronauts. And they wanted to make the people who did that, who designed that system, resilient and use the requisite imagination. They wanted to let them know.
So in John Boyd's OODA loop, there's a pathway that moves from act back to observe. That when we put a boundary around the OODA loop, it's actually a counterfactual. It's a covert feedback pathway. It's about what if scenarios. It's that red. So if you're familiar with Gary Klein's recognition prime decision making, his work there, run in a simulation, right? How do I update my orientation without actually acting on the external environment, running these what if scenarios? So that's already built into John Boyd's OODA loop. And then what we do is in an organization, we create that through red teaming techniques and complex facilitation techniques that we get from Dave Snowden and others to help people imagine a possible future. And clearly you can't come up with a list of 10,000 things and come up with a plan against all those. You kind of have to pick up the most likely, the probabilistic ones and attack those.
And that is, of course, exactly what the people who designed the moon lander had to do. What
Right.
are the things that are most likely to go wrong, and what's the most serious stuff that's going to go wrong, and what are you going to do about it when it happens?
And I think that's an important aspect of when we coach John Boyd's OODA loop, or we train folks to it, is that pathway helps you think through that, the what if scenarios, right? And how do you leverage the wisdom of crowds or multiple perspectives about what could happen? That's an increase of information flow. It's a flow system. That's another way we talk about John Boyd's OODA loop is it has an inlet, has an outlet. It's a great, simple design for or a schematic of how we perceive, plan, act, and adapt in this environment or in this universe. So I love this thinking. And when I read about your requisite imagination, that's kind of, I'm like, I think there's a nice connection there between a lot of things that we're trying to coach folks on.
Yes,
Yeah. I got to throw this out there. So I'm scanning my notes on your book, and there's a connection between Peter Drucker and von Neumann, who came up with game theory, I think it is. Right. So Peter Drucker, Peter Drucker's in the Sidewinder story as an advisor to somebody in DC. One of his technical advisors is von Neumann. Just this past week, I was looking at who von Neumann was working underneath when he's working maybe at Yale or wherever he was, but it was Mandelbrot. And so there's another interesting connection there. And you said earlier, everybody here knows each other, right? The folks in safety, Dr. Spear, a lot of names we've been dropping with you today. It's what's amazing about this is the network that you're in is, in my view, a bunch of mavericks that are trying to help organizations succeed. The problem is very few people are actually listening to you guys, right? That's just my perspective. Any thoughts on that?
Well, it's sort of like, if you go back and talk about von Neumann, this is the top layer of the Rand Corporation were basically people who were like that. Albert Wohlstetter is a person I studied with, was a nuclear strategist, brilliant guy, really extraordinary. But he and von Neumann and other people like that were all into this cool stuff. Mm-hmm. So you might ask yourself, so where are those people today? Well, I sort of felt when I was on the resilience core team that was my version of that, Camelot or whatever you want to call it. But the fact is that you seek these people out. Trent Hone is a person I'd like to meet, actually. I think he's an extraordinary writer, and he's very gifted. And I think the book on the development of the Combat Information Center is just absolutely brilliant.
If you need his email, I'll send that to you. We'll get him on the show. He's on our backlog.
I think he's extremely worthwhile.
Oh yeah.
And I think I've tried to look at the Navy in terms of, okay, what is the role of the Naval War College in all of this? And so let me give you an example. This book came out, It's Your Ship by Captain Abershoff. I'm sure you read it. And he talked about developing a generative culture on the USS Benfold. The interesting thing is that the Naval Postgraduate School actually had done a study of good ship captains. They asked the admirals to identify who were their super captains, and then they went and interviewed the captains. And so that study was done 15 years before Abershoff. And I always wondered, did Abershoff read that book or not? And if he didn't read it, how is it that the Navy didn't institutionalize the insights that were in that study?
Yeah.
And that's an interesting question in itself. Do you have things that are really good that you don't actually disseminate?
Yeah. So I'll give you one that I'm aware of. So I worked with Admiral Stavridis in Europe years ago. We recently pointed out that his understanding of the OODA loop is not great. However, one of the things that I saw in the Navy is he was working with behavioral markers applied to surface warfare, or SWOs, or surface warfare officers. So understanding how to take lessons from human factors, break those down into observable behaviors, and maybe even line them up to your continuum, your cultural continuum there, which we've done successfully with our Zone 5 and our behavioral markers. So in 2017, when we had the accidents at sea, one of my jobs was to go engage with academics and understand how to create, better safety, better culture, higher performing teams. And of course, your work came up quite a bit. And I think one of the reasons for that was this book here, James Reason, Managing the Risk of Organizational Accidents. I think at the time, Admiral Richardson or one of the CNO had read that and said, hey, we need to look at this stuff. And of course, the Westrum model's in there as well. So we're looking at all these things, and I'm looking across the spectrum of what has the Navy done well in the past. And one of them was TADMIS, tactical decision making under stress, but it wasn't implemented. Aviation crew resource management, we know how well that works in aviation. We know that you can scale it. We know it's a foundation for team science. We know it's scalable, given a few changes here and there, not implemented, right? And my question is, why aren't these things implemented? We know better. We're learning these things at War College, Staff College. You look at the book Team of Teams, people get excited about that. I'm like, that's just Mission Command, which John Boyd studied and brought into his OODA loop. It's not new to us. We're like, yeah, we all learned this stuff, but we are never allowed to implement it, right? In my opinion. And we've had Don Vandergriff on the show and Fred Leland on the show to talk about that. We know what to do. We're just not allowed to do it. Right. And in some instances, some people get to that position where they can implement it. General McChrystal being one. It's not that he came up with these things. He was just in a position to implement it.
These people, as they usually get creamed. And so
yeah,
that's the hard part. It's like the way that we treat the creative individual, what kind of aid and assistance they're given, and what kind of supervision. That's all very important. What happens to our technological maestros? I mean, I've studied several of these people, and if you look at the Navy, it's easy to see that you have admirals like Rickover, who are real. Well, you know what they are, but nonetheless, he was tremendously valuable. I've been reading about Curtis LeMay. And the more I learn about LeMay, the more I'm impressed with the man. I think my image of him was always he was kind of a thug. And it's just the opposite. He was a very thoughtful person. He tried to find the best way of doing things, which would kill the least people and so on and so forth. And I think I have enormous respect for Curtis LeMay. But the thing is, again, look at the environment that he was in. Who recognized that he was good? Because he went up very quickly in the hierarchy. But quite often those people don't. They get across somebody else's hawse. There's a problem. Yeah. So. But that's an interesting question. How do you create an environment where these people have a chance to speak up and show their stuff?
Right.
And so the Navy's good in some ways, but other ways, innovators get sidelined, like Tom Lang and the SWAT ship.
Yeah. In fighter aviation, the culture we had there was driven by a couple of things. One, the crew resource management, the fact that we had a process that allows us to be present and focus on the mission, and that's important to be performance oriented. We had an open debrief where it was nameless and rankless. So that ego depletion, ego dissolution, blending egos, psychological safety, however you want to frame it, we created those conditions. We know how to do that. And later on, guys sneak out of the military or sneak out of fighter aviation. They go over to teach on Navy SEALs. Guys sneak out of the Navy and they go teach this in healthcare. And then all these studies come out that go, we went into healthcare and we watched these healthcare teams or surgical teams at work. And we saw this thing called psychological safety. It's amazing. And you ask a question, who trained them? And it's fighter pilots. You're like, okay, do you see the connection here? It's pretty amazing. So,
yeah, no, I mean, I was on the blood safety committee. Briefly, my friend Steve Nightingale was head of it for the Surgeon General. And one of the remits we had was to take the stuff which we've learned in aviation and turn it over to the medical community so they can, use the same stuff like CRM and et cetera. And that was a very interesting process because in the beginning, people were very critical of my being there. And they said, well, you're the college roommate of Dr. Nightingale. And I said, yes. And they said, well, we don't understand why you're here otherwise, So, but at the end of the process, they said, we're glad you're here. This is interesting stuff.
So you've been talking a lot about information flow over the years, the flow of information. I'm not sure if you're working on anything new on flow. One of the things, so I'm a big flow system guy, a flow thinking type of person.
I'm writing a book, and it's basically a series of case studies because that's how I think. And so the first part of it will be case studies associated with pathological organizations. I'm going to talk about Jimmy Savile. I'm going to talk about the Hillsborough disaster in Britain, and on and on and on. Okay, so, and obviously Fox News. There's a whole. It's not hard to find pathological organizations, and then there's stuff on bureaucracy, and it's mostly about bureaucratic failures because that's where we get the most information. Most of the time, if the bureaucracy is working well, we don't pay attention to it.
Yeah.
And then I talk about generative organizations. I talk about the Moonshot. I talk about the Mayo Clinic. There's another thing I'm going to talk about, Fannie Mae. It's probably going to surprise people. But the interesting thing in each case is the specific people, what they did, how they did it.
Yeah.
And the idea of corporate culture obviously is at the bottom of this. But the key is I like to look at the details.
Yeah.
Who were they? What did they do? How'd they get recognized? Why did this work out? Did people transfer the innovation? For instance, in World War II, the Signal Corps invented this wonderful thing called the New Equipment Introductory Detail. Nobody's ever heard of it, okay? You look at the book of the Signal Corps in World War II, and this is mentioned in a footnote, okay? So this NEID was really incredible because it was a brilliant system for getting new equipment into the field, which is part of your OODA loop, whatever it is. But yes, if you have great things and you can't get people to use them, that's not so great.
We had NET in the Marine Corps, the New Equipment Training Team. They would come in. Okay. I guess that's a legacy of that. Yeah.
Mm-hmm. But this is such a great idea. And in fact, the Ford Motor Company's been using this under the system called Industrial Buddy. But it's one of those things that you can't find anything about it. I mean, I the Marine thing I'm going to check out. I didn't know about that.
Yeah, when we had I was an artillery officer, and we had a new fire direction system, and that was what we called it was called Advanced Field Artillery Tactical Direction System, AFATIDS, and we had a NET, N-E-T-T, new equipment training team that would come out to the field and out to the fleet rather, and integrate it.
Okay. Yeah, no, I'm going to check that out.
Yeah. Hey, when we stop recording today, I'm going to send you a copy of the Strength and Gratitude. One of the stories in here is about the implementation of a rover platform into the F-14s. One of my buddies did it. It's an amazing story on how he was able to fight the bureaucracy. Let's think about what you need to do in a 1 month period to get a new capability on a platform like an F-14, how they did it off the shelf. So I'll send that to you. Maybe there's an opportunity to look at that. Back to the flow idea here. Flow is big. Flow is growing in popularity. When you look at a generative culture, the way it's described, in your model there, and you look at the flow triggers that are out there, I'm just going to read a few of them to you. We have novelty, embodiment, clear goals, immediate feedback, passion, purpose, concentration. So you're present. Some risk involved in that. If you look at what we have in your generative side of the house, it's performance oriented, which is mission focused in my view. It's focusing on the outside of the OODA loop, not the ego side. You have the high cooperation. You have the risks again that we talked about just a moment ago. Failure leads to innovation, and failure to us doesn't mean we want to go find failure. We want to increase those aha moments and avoid those oh no moments, right? So how do we seek that? And of course, that novelty. And novelty for us in a flow state is you have more access to information that's external to your OODA loop. It could be your team or your organization. You're paying attention to the outside. You're dominating the competition. So what's happening everywhere right now is the discussion on flow. And I think your work connects directly to that. And I just, you go back and look at it, the DevOps community, what are they trying to do? Increase the flow of information within an organization. What's the OODA loop do? It tells you how to do that. It tells you how the brain works or not necessarily how the brain works, but how we phenomenologically experience the world. And of course, how organizations can do the same thing. So I want to hear your thoughts on where flow is going and how that fits into your model.
Well, basically, the flow of information is something that is absolutely indispensable for organizations. And so anything that tends to get information to flow, and it's interesting, we tend to think about flow as pushing something. but you need to look at how the information is received. The thing about the NEID was essentially that the recipients of the information needed to be properly informed and willing to accept the innovation that came. And in World War II, this was used extensively in the BAT missile, which was about a 1-ton missile that was essentially a glide bomb. So the thing is, you need to think about the recipient, and the generative organization always tends to concentrate on the receiver of the information. What do they need? How is it going to help them? Do they understand the significance? Do they understand the history? And so forth. So this idea of a bill of lading, which I borrow, of course, from mercantile operations, the bill of lading, when the idea comes out, is it given all the peripheral information that is necessary to give it a good evaluation? Oftentimes people don't get that. It's like what you said about the alt report. It didn't just come out. No, you have to look at the mechanism. How is it that it worked? Well, the same thing's true about a bill of lading. When you get a new piece of equipment, do you get a chance to talk to the designers? You know what they built into it and what they didn't build into it. I was in the automobile industry. It was amazing to see how many things the engineers created that they didn't know how to talk about. Okay. And so one of my friends basically offered to be a translator from the engineers of the stuff that they've gotten to the stuff that they were actually selling. Because often the things that the engineers had done were really good, but they didn't know how to tell people what was good about it.
Right.
And so the same is true of new weapon systems. It's true of new medical procedures. I mean, I note that some guy has just invented a better system for resuscitating people who've had a heart attack. And, it enormously changes the probability of coming out alive. Well, that's wonderful. But it takes a lot of outside resources to get that to happen properly. Mm-hmm. And I think that's, this is a good example of the way that you need to surround whatever the innovation is with this bundle of additional information so you can get this thing to work properly.
Yeah. When's your book expected to be out? Your new one? Oh.
I'm writing the book, and everybody says, well, if it was out, I would read it today. Well, great.
Yeah.
The problem is if you're writing it, one of the cases I'm going to feature in the book, which I hadn't thought of originally, is this British post office screw up, where they were essentially torturing these sub postmasters because their machines were doing bad things, and they blamed the postmasters rather than the machines. So something like 900 sub postmasters basically got in trouble, including going to prison. In some cases, they committed suicide. Terrible things happened to them. And it all had to do with the machines not working properly. Mm-hmm. How the bleep did that happen? Well, the answer is that the post office knew that these machines were not perfect. And when the machines showed discrepancies, they blamed the people, not the machines. And so this is a huge issue. There was a PBS special called Mr. Bates versus the Post Office. And
I think I saw a story on this in the past, so it might be the same one.
Yeah, well, anyway,
like you said,
the English called me about this, and they said, "Don't your theories have some bearing on this?" I said, "Absolutely." Mm-hmm. Perfect example of a pathological organization.
Okay, you asked me earlier, or I saw something about UAPs or UFOs. Anything you want to bring up there?
Well, this is how I got into information flow. I began to look at hidden events. Okay. Hidden events are things that people experience widely, but they don't talk about. So, I'm just going to mention some of the studies I did. The serious studies I did were on sea serpents, meteorites, and battered children. Okay. And the latter two things I actually, I went to the people who were the experts on the subject, and I presented them with the history that I had derived from looking at the records. I actually gave a talk at the Meteoritical Society about meteorites. So the reason I did all this, I wanted to see, okay, if we have UFOs, what kind of information behavior can we expect from the people, from scientists, from organizations, and so on and so forth. Mm-hmm. And so I saw years ago the necessity to gain the information about how we deal with anomalies. And so I thought, why don't we look at some historical cases where we actually know the answers in advance and see how they got to those answers. So the battered child syndrome is a good example. It's happened basically in the 1950s by some very bright people. Literally, the guy who invented pediatric radiology was a person who first discovered that, you know, children had patterns of injuries that could only be essentially the result of inflicted harm by the caretaker. And nobody wanted to hear about it. This was something that was kept under wraps. And even pediatricians would say things like, if I thought parents would do this to their kids, you know, I'd get out of pediatrics immediately. So then the meteorite thing was very similar. And the wonderful thing about the meteorite controversy is we have a perfect case. We have here's this case in a display case. And you have the head of the British Royal Society saying, if these meteors had really fallen, we would have so strong proof of it at present that we wouldn't doubt it for a moment. The thing is that the information was there, but they didn't know how to recognize it. And so that's the key about hidden events, is that the information is there, but it can't be used because people are not going to report. Sorry? I can't hear you, Ponch.
I'm sorry about that. I'm asking, why can't the information, what's blocking people from seeing that information?
Well, let's take UFOs as an example, okay, or UAPs, whatever you want to call them. The thing is that, you know, people experience these things, but they can't tell other people that they've experienced them. And so I'm working with a bunch of people called UAP Medical Coalition. Mm-hmm. And we're basically trying to help people who are experiencers deal with the close encounters that they had. And essentially, this is something that nobody wants to hear about. They don't want to hear about the relationship between that and what's happening to their kids, what's happening to their spouse, and so on. It's a terrible situation. So what happens when you get a big bureaucracy dealing with something like this? Well, you just saw a beautiful display on television of learned ignorance. And you have the head of ARROW, this big thing that was supposed to resolve all the UFO sightings, saying, well, there's really no serious evidence about this. There's certainly not anything extraterrestrial. And you can see people in the audience getting ready to start screaming because, you know, that's the whole reason we have ARROW. You know, that's the whole reason we do this. Yeah. And this guy says, oh, nothing to it, you know. Mm-hmm. Well, you know, that's not. So as an expert in information flow, I know I'm not supposed to say I'm an expert, but that's my specialty in information flow. It's just so annoying to see people who really think, well, hey, if this stuff was going on, I'll give you an example. I go out to Yakima Indian Reservation. I do a study of all the anomalies that were going on there. Okay, this was 84 or something like that. So I think, well, this is right next to the Hanford nuclear area. So I'll drive over there and I'll ask them. Because if the Indians are saying this stuff, then they are too. So I drive over there and I talk to the director of security. And he said, we don't really have any UFO sightings here. And I said, well, you know, studies show that this stuff doesn't always percolate upward from the ranks. Mm-hmm. He said, let's check that out. He calls up the head of patrol and he said, do you know anything about anybody seeing UFOs? Head of patrol says, no. But there's somebody here who's a 20-year veteran. Let me ask him. Oh, and when was that? Oh, and he hangs up the phone. So that's the problem with these things. That if it's not supposed to happen, you don't want to talk about it.
So we talk about inattentional blindness. We only see what we expect to see, plus the suppression of information if you don't have a safe environment. So these things are combining potentially that if somebody, like take a rainbow, and I understand when you look at a rainbow, your eyes see two different things. It's contextual, right? Meaning that if there's a person next to me, they see a different rainbow than I do because of their perspective. So using that as some context, if we're looking and scanning the universe, just use the universe, for example, some of us are going to see things that others don't. Is that correct?
Correct.
And yet the bureaucracy and the organizations are going to tell those people, hey, 90% of you didn't see this, therefore you didn't see it, right? And that suppresses information flow. And so we're actually working with some Wall Street folks on this to show them that there are things in front of them that are there that they just don't see. And that's a change in orientation, right? It's your orientation, genetics, your previous experience, your culture, and that new information coming in. All of that combines to create your perception of reality. And if you can update that orientation, which is what misinformation and disinformation, echo chambers, and all that, those things that social media are doing or amplifying right now, that's changing orientation. Same with the tablet, an iPad, an iPhone, the internet. It's the epigenetics that are changing our brains are affecting the way we sense reality. Is it possible? Let me throw this at you. Is it possible that our technology, we're going to get a little wooish here, that our technology from our fighter aircraft, our radars, our capabilities is inviting or creating an invitation for whatever these things are to be seen more often? I know that's kind of out of the scope of this whole conversation. I'm just curious about this.
So let's look at the couple of things. One of them is that these things seem to pay particular attention to nuclear weapons bases. SAC bases in particular. Okay, there's a book called UFOs and Nukes. If you haven't read that, you need to read it. It's all about the SAC bases being penetrated and in many cases jerked around by these, whatever they are, UFOs, I don't know. So there's that. The issue of when these interventions, because that's what they are, what started happening is something that is a more complicated matter. And it's difficult to discuss it in a few moments. But basically, the truth is we weren't looking for this stuff before.
Okay.
And that's an important point, because if you look at the meteorite controversy was essentially discovered, or the meteorite phenomenon was essentially discovered by one guy. He was a man named Ernst Chladni. And he was a scientist who definitely was very opinionated, and he was quite upfront about the fact that he believed that opinionated persistence was the key. So he heard about this from somebody, and then he went to the local library in Göttingen, Germany, and he began looking up stuff. This is about 1790. And he said after about 3 weeks, he said it became obvious that sometimes rocks and metal fell from the sky, often making a noise and burying itself in the ground or landing on top of the ground. And so he published this book, and he was viciously attacked, needless to say, by the know-nothings of the time. And in the end, in about 23 years later, I said 23, something like that, there was a huge fall of stones about 70 miles from Paris. And so the Academy of Sciences had somebody named Biot, B-I-O-T, and they sent him to investigate. And he came back and gave report and said, there's no doubt about it. He said, these people saw these stones fall and so forth. And, here's an example of one of them. And so this is actually a phenomenon. This really happens. So after that, things changed, except that by the time Thomas Jefferson was given a piece of a meteorite, he said, I'd rather believe that two Yankee professors would lie than that stones would fall from the air. Nice. Otherwise he was relatively open-minded, but in this particular case, he picked the wrong horse.
Okay. Wow. So information flow, this is key. If we're to summarize this whole episode, is information flow is the currency of novelty. It's, if you think about Stuart Kaufman's, the adjacent possible, or Dave Snow, or not Dave Snow's, but John Boyd's thought on building snowmobiles, recombining things as we get more, we learn more. That's what information flow allows us to do, is do things that we do things tomorrow that we couldn't do today, right? And improve the future.
Well, and the other important point is that we have to look at who's saying this doesn't exist or that doesn't exist. And are they aware of the information flow themselves? In many cases, the fact that they think it doesn't exist is something that keeps them from finding out that it does exist.
Right.
UFOs are a perfect example of that.
There's a saying we throw around. It's you see what you believe, or you believe what you see, right? There's two different ways. And I can't remember who came up with the other idea for an umpire playing, on a baseball field. I see what I call what I see, and they're nothing until I call them, right?
Sounds like Yogi Berra, but I don't know.
Yeah, it could be. Yeah, it could be. So bottom line, information flow is everything. The flow of a currency within a flow system. Dr. Westrum, I'm so happy we got this time together. I'd love to do this again. There's so much more we can dive into with the continuum that you have, breaking it down to behavioral markers. What do those actually look like when you see performance in an organization?
Yeah.
We could definitely have you back on here, but I do want to turn it over to you and have you share out with our listeners how they can reach out to you, where they can find your current work and future work.
Sure. Well, the simplest thing is I'm on LinkedIn, and if you look on ResearchGate and you have access to that, it's easy to get on ResearchGate. Mm-hmm. You can also look at I have 13 of my publications are cataloged down there, and you can download stuff on requisite imagination and generative organizations and so forth.
Great. Well, again, appreciate your time here today. Been looking forward to this for quite some time, and so much more to talk about. Here's what I'm going to do. I'm going to send you Strength and Gratitude. I'll send you a copy of the flow system that I'm one of the co-creators of. And I got a flow book here for a playbook that I can send to you as well. Is there anything else you want to ask of me? And Mark had to step out right now, but anything you want to ask?
No, I just think that all of this is very important. And I think that the study of information flow in the Navy is probably a very productive thing to do. As far as the OODA loop goes, as I say, the thing is you have to think about how big the loop really is. It isn't just a pilot and his missile and the enemy. Right. Sometimes it's a huge bunch of other stuff.
It's fractal. Yeah, we call it. It's a scale capability. It grows and grows and grows. Right. So
that's right.
I agree with you 100% there. All right, sir. I appreciate your time, and we'll talk to you soon.
Absolutely.